Okay, we have a question here, which is a definite integral from 0 to infinity, and the equation is x times e to the power of negative 5x dx. So when we plug in 0 into the equation, we just get 0, but when we plug infinity into the equation, we get an undefined answer. So we replace the infinity with a b and limit it when b approaches to infinity to the question. So in step 2, we just integrate the equation as normal, which we can only use through integration by parts. As we recall, it's integration of v du equals to uv minus integration of u dv. So we get the answer as stated here. So in step 3, when we plug in the integrated question back into the formula, we have to put in the definite integral, which is from 0 to b. And then when we plug in the value individually, we'll get negative 1 over 5 b times e to the power of negative 5b minus 1 over 25 e to the power of negative 5b minus, when we plug in 0, we just get negative 1 over 5 times 0 times e to the power of negative 5 times 0 minus 1 over 25 e to the power of negative 5 times 0. So when e to the power of 0, it's 1. So we get, as we simplify it down, we just get the initial formula, which is negative 1 over 5b times e to the power of negative 5b minus 1 over 25 e to the power of negative 5b plus 1 over 25. So as we see in the graph at the right side, this is the e to the power of x graph. So if we plug in b as infinity, we get e to the power of negative infinity. So as the graph approaches negative infinity, we'll get 0. So thus we can put in the value as 0. So we get, in step 4, negative 1 over 5 b times 0 minus 1 over 25 times 0. So 1 over 25 times 0 is just 0. But for the front part, negative 1 over 5 times b times 0, which is basically infinity times 0, we can't just assume that it's 0 because infinity is not a definite number. So we go through step 5, which is through the L'Hopital's rule, is when you get an improper product, you just use this rule to simplify it further. So we get limit b is to infinity, so we get b times e to the power of negative 5b, and then equals to, we have to bring either one of the product into the denominator. So we choose to bring e to the power of negative 5b into the denominator, which is equivalent to e to the power of 5b. So we at the end we get b over e to the power of 5b. So as we differentiate b with respect to b, we get 1 over, and as we differentiate e to the power of 5b, we will just get 5 e to the power of 5b. So we just put aside the 5 in front of the e, and we just look at the graph again above. As we plug in e to the 5b, which is e to the infinity, as the graph approaches infinity in the e to the power x graph, e goes to infinity. So thus we get the answer as infinity as a denominator, and then b is 1. So 1 over infinity is equivalent to 0. So in step 6, we put back 0 into the equation. Get 0 plus 1 over 25, and the final answer will be 1 over 25. Okay, so we have this question, which is a definite integral from 0 to infinity, when dx over 1 plus x times square root of x. So as we plug in 0 into the equation, we still get undefined. When we plug infinity, we also get undefined. So we shall split the equation into two parts as shown later in step 3. So for the first step, we shall let u equals to square root of x, and the differentiation after that will be half square root of x. So dx will equivalent to 2 square root x du. So as we sub in this value into step 2, we get 2 square root x over 1 plus, notice that the x has been changed to square root of x squared, which is the equivalent to the same thing, times square root of x. So as the top square root of x and bottom square root of x cancel, we'll get 2 over 1 plus u squared, because we let u equals to square root of x. And then the next step, when we take 2 out, for step 3, we split the equation in two parts, which is one with from b to 1, and then as b approaches to 0, and the second one would be from 1 to c as c approaches to infinity. So as you can see in step 3, to the right of the arrow, the differentiation of inverse tangent u or arctangent u is equivalent to 1 over 1 plus u squared. So in other words, the integration 1 over 1 plus u squared is equivalent to arctangent u. So as we integrate it, we get after step 3 will be the limit b is to 0, 2 times arctangent u with the definite integral of 1 and b plus limit as c approaches to infinity 2 arctangent u c1 as c approaches to infinity. So as plug in the values, we must plug in u equals to square root x first, because initially in step 1 we let u equals to square root x. So for the next step, when we plug in the value, we will get 2 times arctangent 1 minus arctangent b plus 2 times arctangent c minus arctangent 1. So arctangent 1 is equivalent to pi over 4, where arctangent b or arctangent 0 is equivalent. And then for the next part, arctangent c is basically arctangent infinity. So as you can see on the graph on the right, or the arctangent graph, as the graph approaches to infinity, it goes towards pi over 2. So thus, we can say that the value of arctangent infinity is pi over 2. Minus with arctangent 1, as shown before, is equivalent to pi over 4. So in step 4, we do the minusing, and then step 5 we get pi over 2, and the final answer would be pi. As you can see for this question, we have a definite integral from negative infinity to infinity, and dx over 4x squared plus 9. So firstly we factorize the 4x squared, we get 2x bracket square, and in step 1 we shall let u equals to 2x, and du over dx will get 2, and dx will get du over 2, and we shall plug in the value back into step 2, where we get half the integration of du over u squared plus 3 squared. So as you can see, we will use a trigo substitution as shown in step 3, where we let u equals to 3 tangent theta, and we plug that into step 4, and du equals to 3 sec squared theta d theta, and we also plug into step 4. So we will get 3 sec squared theta over 3 tangent square bracket theta plus 3 square. And just below step 4, as you can see to the arrow, we shall use the identities where sec squared theta equals to tan squared theta plus 1. And we apply these identities when we can actually can see that we can sub out 3 square. So at the end we get 3 sec squared theta over 3 square times sec squared theta. And as we factorize the one of the 3 out, we actually get 1 over 6, and the 3 sec squared theta will cancel by itself, and we get integration from negative infinity to infinity d theta as shown in step 5. And firstly we must break these two out, which will limit b to negative infinity and integration of b to 0 d theta plus limit c to infinity, integration of 0 to c d theta. We need to break these two out because if we sub infinity in directly, we won't get we get an undefined answer. So as we proceed to the next line, we actually, after integration of d theta, is actually theta. So because the definite integral is based on in terms of x, so we need to sub theta as in terms of x also. So as we can see in step 6, where we get 3 tangent theta equals to u, based on the before step 3. So when we find in terms of theta, we will get theta equals to arctangent u over 3, and when we sub u equals to 2x as step 1, we will actually get arctangent 2x over 3, and we sub this value arctangent 2x over 3 as theta, as you can see at step 7, when we sub in the values, so we will actually get arctangent 0 minus arctangent 2b over 3, where b approaches negative infinity, plus with limit c to infinity, arctangent 2c over 3 minus arctangent 0. So as we can recall from the previous graph, arctangent 2b over 3 is actually, as b approaches infinity, is actually just arctangent infinity. So as the graph approaches to negative infinity, as we limit b to negative infinity, it actually approaches a negative pi over 2. And then as the graph approaches to infinity, as we limit c to infinity, the graph actually goes towards pi over 2. So as we can, when we sub in the value, we actually get next to step 7, we can see 0 plus pi over 2 plus pi over 2 minus 0. So at the end, we actually get 1 over 6 times pi, and thus we get the final answer as pi over 6.